We have already finished adding the monolithic slabs on the levels, and there are only one slab which are not added on the construction. It is top slab, so our overlapping of our building. Before I will add that slab, I want to select the previous slabs. I will draw according to the shape. For nodes, female shapes. Um, will use fragmentation, and I will need to add the stiffnesses. I will go to the stiffnesses, will select the monolithic slab. Now I need to create the additional parameters for monolithic constructions. I will press button to the edit, go to the add. In the variant of analysis type, I will use slab for flexure. Here I will write monolithic slab. Slab. Press OK. So for concrete, I will select the class of concrete 25. It is heavyweight concrete. Parameters natural hardening, very standard. That's all. And reinforcement. Reinforcement will be the same like for longitudinal direction in X and YZ, and for transverse it will be A2, so reinforcement A2. Okay, so now I will press button to the materials and apply. So the color of elements was changed. It can only mean that the stiffnesses was added. So we check that stiffnesses is on the requirement place. Now we will press the button restore models, and we need to add the top overlapping. For before I will do this start this processes, I will select the monolithic top slab. I need separately actually the thicknesses and the internal and external characteristics of the slab is the same in both of these variants. But sometimes I will need to separately select only top slab, and it will be easier to do if they will be in the other by the created by the other properties, not in the same. So it will be easier. So I will select it, and again I will go to the create or generations of slab. Generation of slab. Here's the same positions, 1 meter 60 times and 1 meter from another also 60 times. I will just show the top node, and it will cover all our building. So we finished with the slabs. What else? Now we can add our foundations. So let's start with the creating foundations. So let's think that our first level of our building will be basement level or underground part of our construction. So it will be substructure of the building. So it means that there are no special requirements for the foundation according to the depth of foundation. So if there are no requirements of the depth, I will apply the length of my column part of foundation equal to chest, it will be maybe 1 meter, and the thickness of the monolithic slab is a half meter. So what I will do, first of all, I will add one knot. So the position of the knot or coordinations of the knot will be minus 1 meter. So here is the knot. It's located beneath this point to 1 meter. So from this spot, from this node to this node will be located my under column foundation. So I will select in the stiffnesses and materials under column part. Then I will use add elements and will show one element. That. So for this element I will select it, go to the material properties, reinforcement concrete type, will add this element. This is the column for ground floor. Here I can write the same what I wrote for the stiffnesses on the column part. The press apply because I will not change the reinforcement and class of concrete. Press button apply. Okay. And so the last thing what I need to do with my foundation, it is to create the mm, foundation base. Foundation base have the size 2 and 4 meters to 2 and 4 meters. So this part, so this node will be center of that foundation. So to find the coordinations of the base of foundation, I need to know the size of it. I know it actually, 2.4 to 2.4. It means that I need to make the copy of this node to the next position by the parameters. It is will be on x direction minus 1.2, and by the y direction also 1.2 with the minus. Now I will check the information according to z minus 1 and according to the y and x minus 1.1, 1.1. Okay. So now I will select the foundation base. Again, use the option create slabs. But in this case, I will use not uh, the section equal to 1 meter. It will be section with okay, let's see, so 0.8, 4 times 0.8, and again 4 times. Oh, sorry, 4 times. Okay, what we have? We have not that what we need to have. Um, maybe not 8. I think mistaken. 0. 0.6. 0. 0.6 will be right. 0. 0.6. Let's see. Absolutely. 0. 0.6. So, very important that column should be located in into the interaction between these sections in the central part. So it is important for transmission the load. Okay, so that is not all. First of all, I need to delete all the rigid restraints because our building will be not rigid building. It will be supported by the soil layers. The soil layers will be added some later, but mm, before it's not so later, I will select all of the rigid restraints and I will add my own restraints where I need it. And I need it on the edges or on the perimeter of the my base of foundation. So I select the nodes on the perimeter of this base. So it is external edge of the base. Go to the restraints and we'll add the restraint on X and Y axis. That's all. Now I will make the copy of my foundation for each of the column. What I will to do? Actually, the simple way is to select the under column part and select the foundation base. So they are already selected. Now we can use copy for x direction 6 meters. The number of copies 9. Not 9, 10. Mhm. Again, I will select all of them. Go to copy. In this case on y direction 10 times. I'm sorry, not the 9. Here will be 6 and 10 times. That's one. We have already finished of creation foundation for under our building. Now we are going to add the, oh, we did not add it into the stiffnesses. It is our external wall. Let's see. We have, according to the initial dates or according to our task, let's say so, the thickness for the external wall made from the bricks. The thickness for my wall will be 0 0.25. And the another thing which I will add, as my building have substructure, so it's a level beneath the 0 point. I will use not only walls made from the bricks, but also I will use the monolithic walls for my external part of the building in the substructure. So what we need to do, let's first of all add the parameters of our wall. It will be easier to make the copy of some of previous plates, to not create the new one, make copy, then go to edit it. So the model elasticity will be the same for the monolithic uh, wall for underground part of the building. Thickness will be 25, the same like according to the task. It's 25, okay. And here I will write that is monolithic, um, maybe substructure wall, monolithic substructure wall, monolithic substructure wall, okay. And again we'll do one copy of this stiffness and edit it. And in this case I will use let me see, let me see, for the brick I will use the model of elasticity, um, 480 and 123 zeros. So it will be model elasticity for the brick. You can accept your own model elasticity characteristics from the LIRA SAPR. So you can open it, and when you will apply the material properties for the wall, there you can open the window with the information about types of the bricks, the model of elasticity there will be the same for each of the bricks and so on. You can accept it for yourself. And the Poisson coefficient will be 0.25. The density of the element 1.8. The thickness will be like it wrote in the our task. So it will be not monolithic, it will be masonry, masonry wall, masonry wall. Okay, that's all. Okay, let's begin work with the monolithic slab, monolithic wall. Check, we select it, and we go to our place of installation this wall. So we have the length 6 meter, we have the height 3.7. Where go to the create of wall beam. This direction is the x direction. This table is for the z direction. What I will write in this case? I will write 1 meter according to the uh, divisions, according to how we divided our horizontal plate. We divide it into the sections which are equal to 1 meter. Yes. Next, I will need 6 times for 1 meters, and according to the height, 3.7. Um, 3.7 can be applied by 1 meter 3 times and 0.7 meter 1 time. And I will show this note. So I have already created, automatically created and added plate, uh, not plate, wall. Um, what can I do next? I will make the copy of this wall. Go to the stiffnesses. Again, we'll select it by the parameters in X direction and 9 times. Now I will select all of the walls and will make the copy by the parameters. In Y direction I will write 60 meters, so one time. Automatically a program will make a copy on the opposite part of this building. We can also made it by using another options like copy by nodes. We will just will need to show the node in the opposite part of the building, right? Now we need to add the wall to the cross-sectional direction, in cross-sectional direction. So what we'll do, we'll use the wall beam. Here we will write the angle of the rotation 90 and we'll select this node. We see that the wall is um, successfully added. What we will do next, how we can select this wall to make the more copies. We can use the option of selecting. We will select the nodes, select the elements, and by the simple way will be select this wall. So we selected it. Now we can make the copy by the parameters y direction 6 and here we will write 9 copy. Okay, now we can select all of them. Actually, there was another way. In the stiffnesses, we need to separately write the wall in cross-sectional direction and the monolithic wall in longitudinal direction, and accept the especially various parameters, various names for the walls in two directions, and it will be easier to select separately both of them. But there are actually no reason to do it for the monolithic slab because we'll not use it in the next hour steps. But when we will create the masonry wall, we will actually add in the two additional two separately ways, the cross-sectional and the longitudinal direction this walls. Okay. Uh, so I will make the copy in opposite path again by using the option copy object um, in y direction 0, in x direction minus 60 one time. That's all. Maybe it will be right to save my model because it was unsaved. And if there will be some problems, it will be difficult to find the information about it. Mhm. Okay, let's continue. So we finish adding the monolithic wall, and now we can start adding the masonry walls. But before we will start adding masonry walls, let's see or look to the requirements for our openings in the wall. The size of our openings in 1.2 meter to 1/2 meter. We need take this information into account when we will add information about size of um, our elements of the slab, which was divided into into 1 meters. So in this case, maybe the divisions of the according to the groups will be another. But let's start. We'll see how we'll divide it. We need to create one wall. We will select the, but before we'll select it, let's divide masonry walls into the two positions, cross section and longitudinal direction. Or maybe it will be easy masonry wall 1, masonry wall 2. So in x direction it will be 1, in the y direction it will be 2. Okay, now I will use masonry wall 1. So what I will need to do, I go to a wall beam, and here I need to write the next information. So as for me, it will be easy to use the size of um, uh, the elements in the x direction, which are equal 0.5. It will be 12 time, and according to the length of the building, so the length of or width of my window will be 1.5, and the height of the window will be 1.2. um, so the window will start in the height 1 meter, so here will be one time. The next will be 1.2. It will be height of my window. Next, I will divide into 1 meter. How many times? Let's see. 3.7 I have already. 1 meter. One time. And half meter. One time. That's all. So let's see what we have. I show the note and what I find. Let's look. I find the thing that I firstly need to select three elements. Is it right or not? Let's see. But my building now, my opening now located not in central part. Actually, it has the right uh, length and right height according to the task 12215, but it's located not in central part of my building. Uh-huh. So what I will to do? I will 6 meter. So to write applying of to the 6 meter, I need to replace my window to the left part to the 0.25 meters or 25 centimeter. If there are actual special requirements, so we need to look at it. Mhm. Okay, so I will go back. First of all, I will at the position 0.25 one time, or, or maybe there are no reason to make it. I think I will not actually do it. Maybe the window located not in central part of the wall. Why not? There are just 25 centimeters. But if we need to do, we just need to divide for right, for example, not for half meters. So we need to divide to maybe 25 centimeters in length. In that case, we can change more little pieces and it will be equal in the central part. For example, 0.125. In that case, it will be divided right. So how many times we need? For 120, 24. Here we need to write 48 elements. So let's select the node. So in this case, we can divide directly um, the central part of our wall and select all elements what we need. That's all. Let's see. 25. Okay, that's it. So now we have the length of our window 1.5 and the height 1.2. The right question, so need we do the same thing or not? You can apply for your own self. So it's all according to the architectural solutions of your building, especially. But I will go to my first decision 0.5 12 time. I will add it. And I will apply the window, or maybe I will change the length of my window. Why not? For example, I want the biggest one. So let's see the size of my window. It will be 2 meters to 2.2 meters. Why not? Interesting variant with some bigger in the size windows. Okay, let's make the copy of this wall in the other steps. So I select this wall, go to copy by the X direction, 6, 9 times. Again, select all of them and press copy. 8 times. 3.7. Again, I select all of them, or not 8 times. It should be 7 times. Copy 3.7, 7 times. Right. So in y direction to 60, 1 time. So we finished with the wall 1. So the next our step will be is adding the wall number 2. Uh, it will be perpendicular to the wall number 1. It will locate it in the y direction. So let's add the first wall. We select masonry wall 2, go to wall beams, write the 90, and choose a node. Here we'll do openings, and make the copy of this wall to another 9 steps. I select